Hello everybody, this is lesson 9.2, the law of sines. So please print out the notes and follow along. So here's the law of sines. And the nice thing about the law of sines is everything we've done up to this point, sine, cosine, tangent, secant, cosecant, cotangent, have been in right triangles. So we're always looking at the ratios of sides in right triangles. When we're using sine, cosine, and tangent, cosecant, secant, and cotangent. Well, the nice thing about the law of sines is it's the first definition or law that you can use use it. It does not have to be a right triangle. So it says here that you can solve oblique triangles. Oblique triangles are any triangle that is not a right triangle. So what it says is that the sine of an angle exist in a proportional relationship to the side across from it. Okay, and so this is true, and when we use this, we typically just use 2 out of 3 parts of it. But it's the sine of an angle over the side across from it is equal to the sine of an angle over the side across from it, and then it's true with the third one. And you could use, this is called the law of sines. You'll need to have it memorized. And you can use it to either find a side length or an angle measure. Okay, but this is the first time when you've been able to use trig in a triangle that is not a right triangle. So if you look, you have to fill a bunch of stuff in here for the triangle. So go ahead and fill that in. This is asking for find AB. So that's asking for side length. It's asking for this. Okay? So you can set up a law of sines with it. So in the law of sines, you always have to use the angle and the side that are across from each other that you know. Okay? So you have an angle and a side across from each other. So it's always the sine of that angle over the side across from it, 7, equals, and we're trying to find this right here, find AB, so it's talking about this. And another name for this is lowercase c. And then you would do sine of 53 degrees over lowercase c. So there it is. So now how do you solve this? This is a proportion, and you know 3 out of 4 things. You know those 3 things. A proportion, just like in 005 and 006, you always cross multiply. So you set the cross products equal. So this one would be C sine 44 degrees equals 7 sine 53 degrees. Remember, you're solving for side length C, and that's just a number. Sine 44 degrees is just a ratio. So you would divide both sides by sine 44 to solve for C. Okay, so let's go to the calculator. Oops. Okay, so big thing, make sure your calculator's in degree mode. I would use the stackable fraction here for sure. So we're going to type that in. Okay, so there's what my calculator looks like. You get, let's see, how are we rounding? The nearest hundredth, so 8.05. Okay, I put little c there. It's also AB, so C equals AB, and it equals 8.05. And that's it. So let's look at the next one. You have to find BC. So BC is this distance right here. It's otherwise known as little a. Make sure you write down everything here that's in purple, because this would have been given to you in a diagram. So law of sines. So you always have to use a side and an angle across from each other that you know. So you can find this angle by adding those two together and subtracting from 180. So let's do that. Okay, so this angle is 29 degrees. Add those two together and subtract it from 180. So now you're ready to set up your law of sines. So you always have to start with the angle and the side that are across from each other that you know. You have to have that as 1/2 of your proportion. So sine 29 degrees over 16. Okay, you're looking for that side. So you're going to use the angle that's across from it. So the other half of the proportion will be sine 93 degrees over A. Okay, it's always the angle on the side across from each other and the angle on the side that are across from each other. So how do you solve that thing? Cross multiply. So here you get A sine 29 degrees. Remember, when you cross multiply, it's always an equal sign between them. And that's 16 sine 93 degrees. Okay, how do you solve that for A? Well, remember, this is A times sine 29, and sine 29 is just some number, some ratio. So divide both sides by sine 29 degrees. So you're just going to type that all in your calculator. It's BC, which is otherwise known as A. Use the stackable fraction. Make sure you're in degree mode. You get 32.96. Okay, so next one. Okay, so make sure you copy down all of these. Okay, so this one's interesting because you're actually finding an angle here. So you need to start with these two. Okay, and you're trying to find that angle. So sine of 88 degrees over 26. And then you're trying to find that angle. So you'll use that angle and the side across from it. But now that you don't know this, so it'll be sine of C over 21. Okay, cross multiply. 21 sine 88 equals 26 sine C. Okay, so look at this. This is a little bit different. So you're going to isolate the sine C because you're trying to solve for C. So you'll divide both sides by 26. So where can I go with this? I'll go down here. So sine C, divide both sides by 26. You get sine C equals 21 sine 88 degrees divided by 26. Okay? You can type this into the calculator. We're going to talk about this. Okay. So just keep that on your calculator. There it is. Okay? It's 0.807. So you have sine of C equals 0.807. Okay, so how would you solve for angle C here? Just think about this. This is telling you sine is equal to this, and that's just some number, that's a ratio. So how would you actually solve for the angle? You would use inverse sine. So do inverse sine of this value, and you'll get the angle C, because this is saying sine is equal to that, and you want to find what angle. So C is equal to inverse sine of that thing. So here's how I'm going to do this in the calculator. sine inverse, and you can use the answer from up above by doing second and negative. There we go. And it says round the angles to the nearest degree, so I'll do 54 degrees. So just look at the difference. Here we ended up with sine equal of an angle equals some number, and you had to use sine inverse to solve for it. It was different from when you were solving for just a side length. Okay, the difference is here you were solving for an angle measure. In those previous two examples, you were solving for a side length. So another one, okay? Make sure you write down all the measurements here, and actually I had to sketch the triangle in there because I couldn't draw that one on the computer. So go ahead and write it down. You're trying to find angle A. So the law of sines you're going to set up is, remember those two always go in there because they're the side and the angle across from each other that you know. Sine 129 degrees over 33 equals, you're solving for angle A, so sine angle A over 11. Cross multiply. Set the cross products equal. So next step, divide that thing by 33 to get rid of the 33 because you're trying to isolate the sine A. So you're going to have sine A equals 11 sine 129 degrees over 33. So I would type that into the calculator and keep the value there. Okay, so there it is. So it's 0.259 about. So sine A equals 0.259. So remember what this is saying. This is saying you know the sine of some angle is equal to that number. How do you actually find the angle? You do sine inverse. Okay, and I will never round that number. I'll always just keep that number in the calculator and use the unrounded version. You can use the answer here. So 15 degrees. I'll be back with the rest.